This is Ham College, episode 101, for June 2nd, 2023. Ham College is brought to you by Icom. Keep your competitive contesting edge and be a field day leader with Icom. Good evening, everyone. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And we're back with some more most excellent questions for you tonight from the Amateur Extra Exam Pool.
I hope they're most excellent. Should be entertaining.
Should be that, if nothing else.
Yeah.
A few tough ones in here. Well, maybe more than a few, but we'll see. I don't think they'll be as tough as last time around.
Let's hope.
Yeah.
Although we did better than I thought last time. I did.
Yeah.
Could have been. Could have been worse.
We did much better than I thought we would last time.
Yeah.
And speaking of last time, last weekend we shot the most recent episode of Amateur Logic, where we had coverage from Hamvention 2023. Mike was there. Chip was there.
You were there.
I was there.
Everybody was there but Emil and myself.
Yep, that is true. And we made up for it. We, as much as we could. Now, you know, there's nothing like going to a ham fest with a guy who's only got $1. You just, can't everybody make that claim, you know.
No, that is true.
But anyway, well, we had a good time. And some pretty good video segments, I think. Yeah. I mean, when he takes a picture of it, giving it as a tip to the bus driver.
You just want to remember what this dollar looks like.
Yeah,
I'm not going to see another one for a while.
And then I'm buying his pork chop sandwich for him. You know? Anyway, if you haven't seen that episode, go check it out. It's Amateur Logic. What was that, 181, I believe.
Yep.
Fun times at Hamvention. Looking forward to next year. See how that comes out. Speaking of things that have already happened, what did we talk about here last month?
Let me see if I can remember. I think it was about, if I can read my writing on my memory, I printed the notes out, except I printed the wrong, I was in a hurry, and I ran in there and printed, and I printed the wrong months. It's not the first time that's happened.
Yeah.
I think we talked about oscillators, signal sources, types of oscillators, synthesizers, and phase-lock loops, direct digital synthesizers, stabilized thermal drift, some other stuff, and high-accuracy oscillators.
Okay. Well, since we've already talked about other stuff,
Microphonics.
There you go.
So I knew it was something like that.
Well, what do you say this month we use the microphonics to talk about AC waveforms, sine, square, and irregular waveforms, AC measurements, average power, and PEP of RF signals, Fourier Analysis, analog to digital conversion, advantages of digital communications, and stuff like that.
That's a lot to talk about with just 2 pages of stuff.
It is, but there's a lot that you have to put in between the lines on here.
Okay.
Believe me, I've got a 3rd page, and it's full.
Oh, it's got the part from between the lines?
Yep, it does, mostly. So, here's the toss. Call it.
Heads.
All right, I don't remember who received last time. I think I did.
I don't. It doesn't matter. I'll go ahead and take the beating first.
Okay.
Thank you, sir. May I have another?
All right. Well, let's see what the first one's going to be tonight. A good one. What is the name of the process that shows that a square wave is made up of a sine wave plus all its odd harmonics? A. Fourier analysis.
B. Vector analysis.
C. Numerical analysis.
Or D. Differential analysis. And I might actually know this one. Or at least I think I have a hunch that it's A. Fourier analysis. It shows that a square wave is made up of sine waves. I don't think it's vector analysis, numerical, or it's got to be A. I think, at least I think it's A.
I and all the people over in the chat room are saying it's A. So I think you nailed
I
that
have
one.
a function on my scope.
You do have that on your scope. I think I've got it on mine too, since I've got the
Since
same
you got
scope.
the same scope.
Yeah. Fourier analysis. As a matter of fact, in between the lines, I got a little bit we can say about that here. In mathematics, Fourier analysis is the study of the way general functions may be represented or approximated by sums of simple trigonomic functions. Fourier analysis grew from the study of Fourier series and is named after Joseph Fourier, who showed that representing a function as a sum of trigonomic functions greatly simplifies the study of heat transfer. Wouldn't have thought that. The subject of Fourier analysis encompasses a vast spectrum of mathematics. In the science and engineering, the process of decomposing a function into oscillatory components is often called Fourier analysis, while the operation of rebuilding the function from those pieces is known as Fourier synthesis. There's a vast spectrum of mathematics, science, and engineering in the process of doing all this stuff. You don't have to know all that to take the exam.
Yeah, that's a good thing.
That's a very good
Or I
thing.
wouldn't be sitting here an extra.
Yeah.
Good chance.
Okay, next question.
Which of the following is a type of analog to digital conversion? A. Successive approximation.
B. Harmonic regeneration.
C. Level shifting.
Or D. Phase reversal. Which of the following is a type of analog to digital conversion? I'll start at the bottom. Phase reversal. That's just crazy talk there. I mean, you're not going to convert analog to digital just by reversing the phase on it.
Nope.
Level shifting. Best I remember, there were only two levels to a digital signal, and that's a 1 and a 0, or a high and a low. So shifting the level of an analog signal, that's not going to do it. Harmonic regeneration. There again, crazy talk. That's not going to convert analog to digital. So I'm going to say it is a successive approximation. What do you think?
Well, I don't think it's B, C, or D, so I'm saying, yeah, A sounds like could be onto something there.
It's what everybody in the chat room thinks as well. There you go. If it was in between the lines,
Yeah, I was just going to look and see if I could see anything.
there's nothing there. I just looked. I should have had something here to talk about successive approximation, but
That's
I
the
don't.
first time I've actually heard of that.
Is it?
Mm-hmm.
I've heard of it before. In analog to digital conversion.
Oh.
Yeah.
Speak of the devil.
There you go. What type of wave does a Fourier analysis show to be made up of sine waves of a given fundamental frequency plus all its harmonics? Is it A, a sawtooth wave?
B, a square wave.
C, a sine wave?
D, a cosine wave. Ooh, what type of Fourier analysis? What type of wave does a Fourier analysis show to be made up of sine waves given fundamental frequency?
Come on, that's a tough one. I'm going to say that.
I want to say square wave, but I'm not sure. I also want to look at this chat room so bad.
Yeah, I don't know if I would do that.
I'm not going to. I don't think it's a sine wave, and I don't think it's a cosine wave, so it's good. I think it's going to be A or B. I'm going to go with B. I'm really not sure.
Okay.
It's either B or A. It's probably going to be A because I said B. A. I mean
It
A.
is.
Did I say A? I
Your-
meant A.
Your logic was perfect on that.
So I should have went with the A after I said it.
Everybody in the chat room said it's A.
Well, everybody was right but me.
Yeah, I think somebody's been studying. Not us.
Clearly, clearly,
Yeah.
I haven't. I actually have the answers here, but I haven't. I don't try not to cheat and look at it.
Yeah. There you go. You can see all the harmonics there are adding up to create that sawtooth wave. And
Cool.
it's a little misleading there. I better not say too much, but just to say, in the case of a sawtooth wave here, it's all the harmonics.
All's keyword here.
All's kind of a key word on that one. Even and odd harmonics. Next question.
Well, that's one buzzer for the evening so far.
One.
So far.
Let's
We've only
see if we can improve
We're
that.
only on the third question.
Okay.
What is dither with respect to analog to digital converters? A. An abnormal condition where the converter cannot settle on a value to represent the signal.
B. A small amount of noise added to the input signal to allow more precise representation of a signal over time.
C. An error caused by irregular quantization step size.
Or D. A method of dissemination by randomly skipping samples. What is dither with respect to analog to digital converters? A. An abnormal condition where the converter cannot settle on a value to represent the signal. No, I don't think that's it. I think dither is something that you want in the signal, or you add to the signal. B. A small amount of noise added to the input signal to allow more precise representation of a signal over time.
I'll wait till after the end to make my comment.
That's going to be my answer. I'm going to say B.
I seem to remember discussing something about this at some point here along the line. I don't remember the topic, but I do remember talking about adding a little bit of noise.
I think we may have been talking about SDRs. I'm not sure, but that is, you're right. That has come up before. C, an error caused by irregular quantization step size. No, it's not an error. It's something, it's a technique we use to improve things, so it's not a method of dissemination by randomly skipping samples. That wouldn't improve things. If you're randomly skipping samples, yeah, that's not really going to recreate what you're
That's lossy
what you're trying
compression.
to. Yeah. Let's see. And it is B. What did the chat room say? A little mixed on that one. What of the following instruments would be the most accurate for measuring the RMS voltage of a complex waveform? A grid dip meter.
B, a d'Arsenal meter. I probably butchered that.
Close enough. C, an absorption wave meter.
Or D, a true RMS calculating meter. Well, following instrument would be most accurate for measuring the RMS voltage of a complex wave signal. That's going to be D, a true RMS calculating meter.
Okay.
There's D's floating by left and right over here.
Yep. If you were to read all of those, what would it sound like?
My
Okay.
bad Morse code.
I'm going to agree with you.
Oh, that's bad Morse code?
No, the
Both?
true RMS calculating meter. And it is. And yeah, that's so you already know what the true RMS thing is all about because of doing electrical work in the past, and I kind of know about what it is too. Apparently everyone in the chat room does as well, but that's not going to stop me.
But there's something between these lines right here,
Yeah.
and I can't quite make it out.
It's a lot more than you would think between those lines. For the measurement of an alternating current, the signal is often converted into a direct current or equivalent value, the root mean squared. Simple instrumentation and signal converters carry out this conversion by filtering the signal into an average rectified value and applying a correction factor. The value of the correction factor applied is only correct if the input signal is sinusoidal, which it's not always. True RMS provides a more correct value that is proportional to the square root of the average of the square of the curve and not the average of the absolute value. For any given waveform, the ratio of these two averages is constant, as most measurements are made on what are normally sine waves. The correction factor assumes this waveform, but any distortion or offsets will lead to errors. To achieve this, a true RMS converter requires a more complex circuit. The RMS value of an alternating current is also known as its heating value, as it's a voltage which is equivalent to the direct current voltage that would be required to get the same heating effect. For example, if 120 volt AC RMS is applied to a resistive heating element, it would heat up by exactly the same amount as 120 volt DC. That makes sense, doesn't it? Analog electronic circuits may use an analog multiplier in a specific configuration, a full-wave precision rectifier circuit to create the absolute value of the input signal, a log domain precision detector, or a field effect transistor. Unlike thermal converters, these analog circuits are subject to bandwidth limitations which make them unsuitable for most RF work. The circuitry before time averaging is particularly crucial for high-frequency performance. If a waveform has been digitized, the correct RMS value may be calculated directly. Most digital and PC-based oscilloscopes include a function to give the RMS value of a waveform. And got a slide right here from Rockwell Automation. Actually, it is their website. They're showing the different multimeter types. Average responding meter, which is your typical old school meter, or a true RMS meter. Response to a sine wave, both of them are correct. If you got a pure sine wave going in, they're both going to read the same thing. If you got a square wave going in, your average responding meter is going to read 10% high. And that's because it's not factoring in, I don't know if the right word is a duty cycle, but the waveform itself. If you're looking at a single phase diode rectifier, the average responding meter is going to be 40% low. True RMS is correct. In response to a three-phase diode rectifier, it's going to be 5 to 30% low on an average responding meter and correct on a true RMS meter. It's kind of important if you're looking at signals and you really need to know what the true voltage is of it, you're using a true RMS meter. Most all of our old school meters were average responding. They were not true RMS. Now, I purposely bought a true RMS meter a few years back for doing transmitter work. I've had one at previous jobs before, and the reason is pretty critical. in tube circuits. Now, you probably wouldn't do this for your home amplifier and stuff like that, because tubes are not quite as costly. But, when you're spending a couple of $1,000s on a tube, you want to get as much life as you can out of it. And the filament voltage is critical. You want to run that filament voltage at a particular amount for the first 200 hours of the tube's life. You want to run it right on the rated voltage. And the waveform that's coming in from the utility, and by the time it goes through your transformer and your rectifiers and your filtering and all, to drop it down to a DC voltage to heat those filaments, probably in the range of maybe 6.3 volts or maybe 7.5 or 10 volts, depending on the filament voltage rating of that tube. It's going to vary. You want that, if it's rated at 6.3 volts, you want to run that tube right at 6.3 volts for that first 200 hours till it gets cooked in, seated well. Then you can back the voltage down. And by doing that, now this is for fluorinated tungsten type filaments, which most of your home amplifiers are not going to be, that's not a concern with them, but fluorinated tungsten like we use in broadcast transmitters, tube type ones, it's pretty critical. So after you've seasoned that tube at 200 hours at the rated voltage, you can drop it down until you see the power start to back off a little bit. Then you increase it a little, just right above that point, so that tube will sit there and it's running cooler. Still putting out the same amount of power, but it's running cooler, which means that filament's going to have emissions longer. If you run it at the rated voltage or over the rated voltage, the tube's going to play out faster, because usually what goes bad is it boils off all the tungsten off of the filament, or fluorine, or
something.
Something. It boils it off, as it's emitting electrons. That stuff is boiling off, and the hotter you run it, the faster it's going to boil it off. So you're trying to extend the life of the tube, so it's pretty critical. If you're looking at true RMS value to adjust your filament voltage, then you know that you're doing what the manufacturer recommended. If you're using your Simpson 260, you might be up or down a little from where you should be, and just a few tenths of a volt can make a difference in an application like that. So that's one reason.
So you run that for 200 hours
at the rated voltage.
Set it and leave, and then you go make sure you're back there when the 200th hour's up.
Yep.
No matter what time it is.
You should. I don't always. I mean, I might go a day or two over. That's about a week, roughly in the neighborhood of a week. So I'll wait a week. I'll wait at least 200 hours and then go in the next day or two and turn it down and get a longer life out of the tube. It does make a difference. What do you say we take a break right here? Because it did kind of warm up when we were using that average responding thermometer over here.
Yeah, my tungsten's about to it's getting pretty toasty.
Well, that's a good enough reason right there. Keep your competitive contesting edge and be a field day leader with Icom. Field Day is amateur radio's most popular event and is just around the corner. On June 24th and 25th, more than 40,000 North American hams will come together to operate remotely. Icom's robust and high-quality transceivers easily cut through pileup, so you can work the bands and make those contacts. Icom is the clear choice for DXers and contesters around the globe. Explore the world of microwave with Icom's new SHF portable, the IC905. This all-mode rig covers 2 meters, 70 centimeters, 1.2 gigahertz, 2.4 gigahertz, 5.6 gigahertz, and with an optional CX-G10 transverter, 10 gigahertz. This transceiver also has a few industry firsts up its belt. It's the first to support the 5 major global bands from VHF to SHF. The first Power over Ethernet powered RF module designed to be at the base of the antenna to eliminate signal loss, and the first to be compatible with Amateur.TV in analog FM mode. Other features include large 4.3-inch color touchscreen, real-time high-speed spectrum scope and waterfall display, easy digital mode settings, supplied high-performance GPS antenna, full D-Star functions for DV and DD mode, and an SD card slot. Aim higher and enter the world of SHF. The Icom IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. This innovative HF transceiver digitizes RF before various receiver stages, reducing the generated inherent noise in different IF stages. This is the radio that changed the way entry-level HF is designed. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The real HF fun starts here. Create your own band opening with the IC9700. This radio brings direct sampling to the UHF-VHF weak signal world. The IC9700 is an all-mode transceiver loaded with innovative features that are sure to keep you busy. Expect top performance on field day with Icom's IC9700. The IC7610 is the SDR every ham wants. This high-performance SDR can pick out faint signals in the presence of stronger adjacent signals. The Icom 7610 is a direct sampling, software-defined radio that's changed the world's definition of an SDR transceiver. RF direct sampling, 110 dB RMDR, independent dual receiver, and dual digicell. For more information about all the great Icom radios, visit icomamerica.com/amateur.
Well, let's give away a shirt then.
The shirt off of my back?
One just like it.
Okay.
Look, two-sided T-shirt. Ham crew on the front, ham crew on the back. What is it we say every time?
You look just as good when you get it to Hamfest or when you leave the Hamfest.
You did when you got there.
If you'd like to win that,
send an email to hamcollege@AmateurLogic.TV. Just give us your name. If you want to put a note in there, like this month's winner, you can. Not required.
What did he say? Who was it?
Actually, the this month's winner is Richard Kirsch. I hope I said his name right. K1CBW says, thank you. I'm a fan of the extra classes. At 84, I'm not sure I can retain enough to pass, but I'll try. Dick. And I bet you can. I bet you can. So you got our vote. If that counts for anything.
Well, he'll be wearing this shirt right here, so regardless,
good luck shirt.
He will look just as good when he leaves the exam session.
Yes, sirree.
As he did when he got there.
And hopefully with a ticket. I bet you will.
Yeah.
I bet you'll get it.
Okay.
So when you pass, let us know you're another Ham College graduate, as a matter of fact.
There you go. You know, we need, and this sounds like a job for VE3MIC.
Yeah.
We need diplomas.
Yeah.
I hesitate to suggest that to Mike because there's no telling what he would come back with. But
well, you just did suggest it because he's out there.
Yep. Yeah. Too late. I didn't hesitate enough, did I? Oh, he says Professor Thomas was Julia Childs of electronics. No.
Is that good?
No, I'm not sure. I'm not sure about that. Something tells me it's not what I strive for. Mission accepted. Okay.
She's the one that was some kind of a secret agent spy thing or something, wasn't it?
I think she was a cook on TV.
I know she was, but she also had another.
Well, so there could be similarities in our careers then.
Began her work with the Office of Strategic Services, predecessor to the CIA.
Oh.
So that's you.
Mm-hmm.
The G-man, George.
Okay.
The G stands for George.
Yep. I'm not going to suggest you try my cooking, though. What is the approximate ratio of PEP to average power in a typical single sideband phone signal? Is it A, 2.5 to 1,
Yeah. B, 25 to 1.
C, 1 to 1?
D, 100 to 1.
This is easy. You got this one.
Do I?
I think you do. A little reasoning. I think you'll get this one.
Well, I don't think it's 100 to 1. I don't think it's 1 to 1. I want to say I've seen this before, and I think it's 2.5 to 1, but I'm not 100% sure of that. Approximate ratio of peak effective power to average power. 25 to 1 seems like an awful lot. I'm going to go with A, 2.5 to 1, just because.
That's what everybody in the chat room's saying, and really, that's the one that makes the most sense there. Because
That seems like a pretty excessive amount.
you know, there's conversion factor to convert PEP to average power, but 100 to 1, that's off the charts. 1 to 1's, that's not possible because you didn't convert anything. They're not the same. 25 to 1, that's
still
high.
Excessive.
Yeah.
What determines the PEP to average power ratio of a single sideband phone signal? A, the frequency of the modulating signal.
B, speech characteristics.
C, degree of carrier suppression.
Or D, amplifier gain. What determines the PEP to average power ratio of a single sideband phone signal? PEP, peak envelope power, to average power, the ratio between the two. Well, it's not the amplifier gain, because the amplifier gain is just going to amplify whatever you give to it. The PEP to average ratio has already been determined before you amplify it. The degree of carrier suppression. No, because carrier should be pretty well suppressed. If there's a little bit remaining, it's going to be so low that I don't think it'd have much effect. A, the frequency of the modulating signal. No, that's not going to change the ratio between the two. It's going to be the speech characteristics. Because the reason I say that, when you talk, you're generating a waveform. If the characteristics of the speech are real peaky, real spiky, then the ratio between the peak envelope power, which is going to be those peaks, to the average power, it's going to be farther apart. Because if you're looking at the peaks, that's going to be your PEP power. Your average power, if it's just a bunch of peaks, your average power may be lower. So it's going to be speech characteristics. If you're talking and the speech is pretty leveled out, there's not real high peaks in it, it's sort of consistent, then the ratio between the peak and the average are going to be closer. So I'd say that's the only thing there out of those choices that really change power ratio much. What did the chat room say?
In your ALC setting?
Yeah, that's not one of your options, Mike. Okay, so I'm going to stick with B, speech characteristics, like just about everybody in the chat room except for Tom, who said it's E, how chatty you are. That could happen too. Speech characteristics. So,
I had a premonition that line was going to be yellow. I don't know. It's like I saw it, saw it ahead of time.
You could really get your average power ratio way up if you whistled a square wave instead of a sine wave.
But that's a skill all unto itself.
Well, yeah, I think so. If you're using a power mic, though, you got it covered. Why would a direct or flash conversion analog to digital converter be useful for a software-defined radio? A. Very low power consumption decreases frequency drift.
B. Immunity to out-of-sequence coding reduces spurious responses.
C. Very high speed allows digitizing high frequencies.
For D, all of these choices are correct. Why would a direct or flash conversion analog to digital converter be useful for a software-defined radio? Flash conversion? Direct or flash conversion? Very low power consumption. I'm not sure about this one. Very low power consumption decreases frequency shift. Doesn't seem to make much sense to me. Immunity to out of sequence coding. Very high speed allows digitizing high frequencies. That makes sense. D. I don't think it's D. I think it's C. That's one that makes sense to me. High speed allows digitizing higher frequencies.
That's what everybody in the chat room's saying. I'm going to agree with you. And you're correct. You know, these newer software-defined radios, particularly the Icom ones, they say they're direct digital conversion. So that's the technique they're talking about right there.
Okay.
They call it direct or flash here. I had never heard the term flash before. That's new to me. But,
yeah,
you know, it's digitizing that signal directly. It's not going through all these IF stages in a receiver. It digitizes what's coming in. So, yeah, higher frequencies.
How many different input levels can be encoded by an analog to digital converter with 8-bit resolution? A. 8.
B. 8 multiplied the gain of the input amplifier.
C. 256 divided by the gain of the input amplifier.
Or D. 256. How many different input levels can be encoded by an analog to digital converter with an 8-bit resolution? Well, it's not 8, because an 8-bit number can hold a number larger than 8. 8 multiplied by the gain of the input amplifier, that has nothing to do with it. 256 divided by the gain of the input amplifier, that doesn't have anything to do with it.
That also has nothing to do with it.
Yep. D, 256. Everybody in the chat room saying D, which is what I think it is. I think an 8-bit.
Well, I think it's D too. It's same as VGA color. 256 color.
An 8-bit number can hold, the maximum number you can stuff in there is 256. And it is. Program a calculator. And I'm going to put it on binary. So an 8-bit number, 1, 2, 3, 4, 5, 6, 7, 8. So if I change that to a decimal number, we'll look at here, 255. So 8 bits set to 1 in decimal is 255. 255 wasn't an answer there, but here you go. That's because you could have a 0 in there, which would make it 256 different numbers. What is the purpose of a low-pass filter used in conjunction with a digital to analog converter? A. Lower the input bandwidth to increase the effective resolution.
B, improve accuracy by removing out of sequence codes from the input.
C, remove harmonics from the output caused by the discrete analog levels generated.
Or D, all these choices are correct. What's the purpose of a low-pass filter in conjunction with a digital to analog converter? Lower the input bandwidth. B, improve accuracy by removing out-of-sequence codes from the input. Remove harmonics from the output caused by discrete analog levels generated. Low-pass filter in conjunction with digital to analog. So that's on the output.
Mm-hmm.
I'm going to go with C. Remove harmonics from the output caused by the discrete analog levels generated.
Okay.
I really don't know, but that's my guess. So I'm sticking to it.
So what everyone in the chat room is saying.
But
So,
we could have been wrong together, guys. It's happened before.
I'm not sure. Is this an anti-aliasing filter? Is that the same thing?
I don't know. It probably could be. I
Yeah.
think. Which of the following is a measure of the quality of an analog to digital converter? A, total harmonic distortion.
B, peak envelope power.
C, reciprocal mixing.
Or D, power factor. Which following is a measure of the quality of an analog to digital converter? Well, wouldn't be power factor. Wouldn't be reciprocal mixing. Wouldn't be peak envelope power. It's going to be, the only thing there that's a measure of quality is total harmonic distortion.
That seems to me.
I'm going to say A. Chat room.
A.
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 They all went Canadian.
They did. That is the last question for
No,
tonight.
say it isn't so.
It is so. Oh, maybe I should show the answer. Total harmonic distortion. So there.
Wow.
We got through those with only one buzzer.
You're welcome.
The chat room did very well on these. I'm beginning to think
They must have the question pool open or the book.
that or they've been studying or they're just really sharp. Any of those possibilities.
Yeah, they're probably pretty sharp.
Or it
Actually,
could be,
I know they are pretty
could
sharp.
be cheating. I didn't throw that
Didn't throw
one
that
in
one
there.
out there?
No.
Well,
Yep. Next time I'm going to cover up my paper while we're going over these. Wow. Well, those were not too terribly bad. We got through most of those okay tonight.
well, they were harder last month, and I don't think I had any buzzer last month. I got luckier. Oh,
Was it
I don't
last
think-
month or was it 3 last month?
Was it?
I don't remember.
I think it was 3 the months
Month
before
before.
that.
Okay. Well,
I don't know.
it's not a competition.
All the it kind of is. A little
No,
bit.
I mean, you just want to pass the test. That's the bottom line. It don't matter what score you get as long as you pass,
Yep.
which was my
After all philosophy
That's
all
kinda-
along.
yeah, that's kind of the way it worked
That's
for
my
me.
goal.
I know it was a horrible score, but I passed.
I actually made a pretty good score on mine.
Yeah, I didn't. I don't
But
know.
I studied really hard back right before I took it.
Yeah, I didn't. So it really surprised me I passed it, but I did. You know, it's not everyone who has a Ham Crew t-shirt,
Nope.
although there is going to be one more in our
Pilot
ranks
Institute.
tonight. Pilot Institute.
Yeah.
That's a pretty nice shirt, too.
Yeah,
But you know, it is Hamfest season.
it is. It really is. Hamfest
Oh,
season.
yeah, it is. It's field day season, too. But when you're showing up at a ham fest, and especially like in this case, after a lockdown, when folks haven't seen you for a while, you're a little bit older than you were the last time we all got together. You really need to up your game to impress your friends and
I see where you're going
some
here.
other stuff that's not coming to me right off the
I
bat.
can't say you're not right.
How could you do that?
Well, the first thing that comes to my mind is some cool swag.
The wardrobe.
Got to be looking your best. I think you should go by shop.spreadshirt.com/AmateurLogic. Check it out. There's some cool Hamfest attire on there. Cool field day attire. If you're up north where Mike is, there's some warm field day attire. Actually, it's probably cool. These be cool up there too by then. Anyway, we got cups, mugs, caps, shirts, hoodies. There's little backpacks, all kinds of stuff on there. So go check it out.
We're not suggesting that you try wearing a mug now. But
you could put you something cool or warm in there to drink.
Yep. You could brew you up a spot of tea, which is what I have right here. I didn't notice Nigel say anything lately, so he
2 bags, one for you, one for the pot.
That'd be some mighty strong tea.
That's what you're supposed to do.
I think we were...
Have to have an extra bag, one for the pot.
But that's if you're brewing for more than one person, I think. I don't know.
Well, that's how you can sell more tea.
Well, we did it one time, and the cup is still here. Although there's a little chip missing out of it now. It
must have been pretty stout.
It was. It was some of that British tea. Anyway, that's all we got to say about that. So, wow, field day is upon us.
Yeah, we got AmateurLogic coming up, and then field days directly after that, I think.
Yep.
Speaking of which, AmateurLogic will be on the, what was it, the 16th?
Yes. It will be on June the 16th, Friday, June 16th.
So the LogicNet will be on the 20th.
Speaking on your comment there, so you're saying it's a 2-bagger?
I set myself up for that one.
Yeah, thanks in, Andrew. As a matter of fact, we've started making our field day plans already. We've got a loose plan in mind. We just looked around, though, for the cobweb antenna, and it's not over here where we usually keep the cobwebs.
Did the cleaning lady come dust for cobwebs?
I don't know where it is. I got to look for it. I think it's out here in this other building. But, yeah. So, we're looking forward to field day this year.
I'm not looking forward to untangling that thing.
I'm not either.
I hope we got it untangled when we put it up.
We sure spent long enough it should be untangled. We could have shot a couple of episodes of Ham College during the length of time it took us to untangle that cobweb.
It was hot out there too, man.
Oh, yeah. Yep. Next Ham Fest, I noticed that Chip said his next Ham Fest is Huntsville. That's my next one, too. Already got a room booked over there. IK04. I've forgotten who that really is.
Are we going to use Tommy's big ear? Maybe. We were just talking about that right before the show started.
We could.
Possibly. I'm going to take it for sure.
Yeah.
We're going to be at a different location this time, so got to kind of scope things out and see how it works out.
Yeah, I think it'll work out okay. As far as wide open spaces, we got plenty of those.
I got enough coax to get out there.
That's going to be the thing. So I guess we ought to bring all our coax and our barrel adapters this time around.
What you going to run? Your 77,000, I mean?
I think I'm gonna run a 7,000 again.
I'm going to run my 705 again, man. That worked out really nice for me.
I ought to slip out. I don't know. They may change the rules. I was gonna say I ought to slip out my 7,700 over there. If it didn't weigh 100 pounds, I would.
I don't think I'm going to run off of battery power the whole time with maybe, if I got enough cable, solar backup. I don't know if I'm going to be able to get solar from where we are.
You know, if the sun is out, you will.
Okay.
I need to do something with my solar panel back here. I still haven't charged up my batteries with it. Of course, it's not really going to run a 100-watt rig that long.
No, but help keep the battery charged in between.
Yeah.
Hopefully it'll put more in the battery than you're using. It depends on your duty cycle.
It depends on my ratio of PEP to average power.
Yeah, if you're chatty.
Yeah. Okay. Terrence says his next Ham Fest will be Friedrichshafen. Video to follow.
Yeah, I want to go there.
Yeah,
I
me
looked
too.
at that last year, and it is a journey to get there from here. You got to take planes, trains, automobiles, boats, carriages, all kind of stuff, man.
Really?
I didn't see a good way to get there. Of course, somebody that's been there may know better.
Head east.
Start swimming.
I guess. I don't know.
Yeah, but you get to Germany. When you land in Germany, you got to go a long way. Pretty sure that, remember, there's a lake in the way from where you have to fly into, and you have to take some kind of ferry over possibly, or you go all the way around it. I just don't know. I didn't see a good way to get there.
You have to ask Terry because he knows. Tom says just found a PDF from 1943 from RCA about fluorinated tungsten filaments, and it backed up what you said 100%. Also reduced life from overvoltages on the plate, control, or screen grid. Yeah, all those make sense. What I've read about that, Tom, was in a paper from IMAC. Sounds like they were cheating on RCA's paper, or maybe it's just common knowledge. But yeah, it's a big deal. You buy a at least a Continental transmitter, Continental brand tube type broadcast transmitter. Probably some other manufacturers too. They put that IMAC bulletin in the owner's manual. So you got it right there and can refer to it. And it'll make a big difference in the lifetime of a tube like that that's on 24/7. Anything else we need to mention on the way out? Well, if you're going to college, you probably wouldn't want to be in a sorority, but you could. I mean, there's probably dudes doing that today. Well, I know there was one that tried recently. I'm not sure how that worked out, but anyway, we've got our own high society here for Ham College. Facebook.com/group/Ham College.
We're also on Twitter. Follow us at Ham College.
Or groups.io/G/AmateurLogic. And there in the groups IO, we're just kind of tag-alongs to Amateur Logic on that one, rather than create a separate group. Because same show. Just because, yeah. Anything else to mention? Well, if you need show notes or want to know what episode, what questions might have been covered in, there is a way to find that out.
You can go to the wiki, AmateurLogic.TV /wiki. There's this guy when he does the RSS feeds. Eventually, he always updates the wiki at the same time.
Which is
I'm
a week late now.
The AmateurLogic one, I'm a little behind. I went out of town and had some stuff going on, so it'll be updated tonight before I go to bed.
Okay. All right. We'll be sure to check in.
Yeah, check it tomorrow morning.
Okay.
'Cause I don't know what time I'm going to bed.
Okay. Could be tomorrow.
Could be.
Yep.
Actually, it probably will be sometime tomorrow.
Yep. Well, I think that's going to do it for tonight. We appreciate everyone watching the show here. Study for your exam. Spend a little time going over the books, taking online test, sample test. Just prepare yourself. Get used to these questions and the way that they're asked, and you could be an extra too.
Oh, yeah, no doubt. If I can do it, you can do it.
Same here. Same here. And we appreciate all the folks that hang out in the chat room while we're doing this. It's always good to see them in there and kind of see what they're thinking about things. We can't talk about all of it on the show here. Every now and then there's something, not very often. They're a good behaved group, I'll say that.
Oh, yeah. That's great.
But they do catch things that slip by us from time to time.
Yeah, if you're not in the chat room, you're missing half the fun. I haven't
Question?
said that in quite a while.
You haven't. And the question is?
Which half?
Mm-hmm.
But that's something only you can answer.
Yep. Only you can prevent.
I say we exit out here and turn the air conditioner
There
on.
you
It's
go.
getting pretty toasty in here, man.
Yep. That average to PEP temperature, all of that.
It's off the scale.
Yeah, what were we talking about earlier?
100 to 1.
Yeah, I'm going to have to do some Fourier transforms here and figure out how hot it is.
Some ciphering.
Yep. There you go. 7-3, everybody.
7-3, everybody.